All right. Hello, AP physicists. Yesterday, my computer really did not like doing this problem, but I'm going to give it a shot again so that you can have access to it anytime you need. So this is from chapter 10. This is question number 28. So this is the one that we worked on yesterday. That was Monday, December 10th. And again, it was the one about the ramp that they had the block going down. It started up here. I'm going to call that point A. It slid down to point B where it was moving really fast. And then it was going to slide up some distance up here, C, where it was moving half as fast. And so we wanted to figure out how high up it was at C. So I'm going to define my H equals 0 to be at the bottom so that I can say that the gravitational potential energy at B is 0. I'm going to call this height here H sub A, and we're going to do things in terms of H sub A. And then here I've got H sub C, the height where it is at C. So because it's a closed system, that means that energy is conserved throughout. So I'm going to go ahead and write down a conservation of energy statement. So I'm going to say the gravitational potential energy at A plus the kinetic energy at A is equal to the gravitational potential energy at B plus the kinetic energy at B equals the gravitational potential energy at C plus the kinetic energy at C, which is kind of a long, icky looking thing, but a lot of this is going to go away. We know that at A, the box is not moving, so that means that this one, the kinetic energy at A goes away. And since we set H equals 0 to be at the height of B, that means that the gravitational potential energy at B goes away. So yesterday, when we did this, we used these two to define our velocity at B in terms of the height of A. So we said that the mass times the gravitational acceleration times the height at A was equal to 1/2 the mass times the velocity at B squared. We canceled our masses and found an expression for the velocity at B, and that was equal to the square root of 2 times g times the height at A. So we're going to use that information to now look at the situation at C. So I'm going to take this piece here, and I'm also going to take the potential energy at A just to keep it simple, and I'll also have an expression in terms of my height at A. So I'm going to have the gravitational potential energy at A equals the gravitational potential energy at C plus the kinetic energy at C. I know that this is m times g times the height at A is equal to the mass times the gravitational, I said that backwards, but you know what I'm trying to say. Gravitational potential energy at A is equal to the gravitational potential energy at C plus the kinetic energy at C, so that's 1/2 mv sub c squared. The condition that they talked about was having that velocity at C be half of what it was at B. So I'm going to put in the square root, I'm going to put right here, this is going to be the square root of 2GHA divided by 2 because it's half as big as it was before. So now I'm going to plug that in. I'm also, because I don't care about the mass, going to get rid of those masses. See you later. So I've got G times H sub A is equal to G times H sub C plus 1/2. And I'm going to do the square root of 2GHA, because again, that's the velocity at B divided by 2, and I'm going to square that. So the nice thing about this expression is that everything we have here is in terms of the heights, and that's what we really want. So now I'm going to use this square, and I'm just going to square everything in that parentheses. So I'm going to go ahead and write out everything else just so we've got it all nice and neat. So GHA is equal to GHC plus 1/2. I'm going to square everything inside there, so that gives me just 2GHA on the top because squaring a square root gets rid of the square root. And then I have to square the bottom as well, so that's going to give me a 4 on the bottom. So here we've got a lot of things that happen, which is fantastic. I noticed that there's a G in every piece of that expression, so the G's are going to go away. See you later. And I've also got a 1/2 and a times 2, so I'm going to get rid of those as well. So then simplifying that down, I've got HA equals HC plus HA over 4. And now it's looking nice and clean. We can put all of those HAs on one side, leave the HC on the other side. So I've got HA minus HA over 4 is equal to HC. 4/4 minus 1/4 gives me 3/4. of HA is going to be the height at HC. Hopefully walking through that with me was helpful. If you need to watch it multiple times or if you have questions, please let me know. I hope you have a great day. Talk to you soon.